that were originally, the journal clubs were originally separate entities, but since two of the journal clubs are coordinated by Nigerians, we have decided to incorporate the activities into the activities of the hub, of the National Research Hub. So there's a biomedicine and healthcare hub that I coordinate, and then there's the environmental sciences that is coordinated by Dr. Fumi Doherty, the principal investigator for this National Research Hub project. And because we mentioned it yesterday, I got quite a number of requests, and I'm aware that two of those who wanted to join the social sciences one that is not coordinated by Nigerians, I noticed they were added because we're all members of each other's journal clubs. So that's, I think that's Adamu Usman Aliu and Dauda. No, it's Dauda Ayuba and one Baba Maragan. I hope I pronounced that right. So you might want to take advantage of those two. So there's added learning platform. The activities are not exactly the same. For example, the Biomedicine and Healthcare Journal Club, we're going to have a relaunch of the Journal Club tomorrow morning. And we're also going to have a proper Journal Club review in addition to the launch. So for those who are interested, I've posted on the National Hub WhatsApp, and I'm going to post a reminder again. So please do join us and see how we can be of help to each other. Thank you so much. We're still waiting for our resource person to join. But whilst we're doing that, if there's anybody here who hasn't registered for this event, please take register. That's like attendance. We're taking attendance. We need to present a report of what we're doing. One, then of course we're also collecting information so that we can reach out to you, send you notifications, updates about our activities. Then somebody's hand, was up. Yes, somebody raised hand and now it's gone down. So who is the person? I don't know why before when you raise hand, your name is put on top, but for some reason, I don't know, maybe I need to do an update. Even if I click on the hand, I don't see the person except I scroll. Okay, there it is. Mrs. Salisu, I think. No, Adamu Usman Aliu. Let me allow you on mute so you can speak.
Hello, good morning.
Morning, how are you?
Good morning, Dr. Zainab.
Morning.
Sorry, I want to ask about the attendance. Hello?
Is there anything you'd like to know about the attendance? Anything specific?
Yes.
Okay, what would you like to know, please?
No, I did not sign the attendance.
Oh, okay. All right. So I'll quickly fish for the link and send it to you. I hope.
Thank you very much.
Okay, all right. And thank you to all those who did. And then at the end, we're also going to be sending out a survey so you can tell us what we can do better, what we did really well, and you would like us to improve on, and what you would like us to stop altogether. Thank you very much. We'll send the link. Thank you so much. Thank you. And just in case if I forget, we'll also like to do, for those who are not camera shy, towards the end, please, I'll need you to turn on your cameras so that we can do a group photograph. Thank you. All right. We're still waiting for our resource person. I hope his internet is better today. It wasn't so good on day one. It was much better yesterday. So I hope today will be a lot better than days 1 and 2. Thank you. Okay, who else was here yesterday? Egia was here. Egia, what else would you like? What did you learn yesterday? Did the workshop meet your expectation? And if it didn't, what should we do better? I'm going to have to allow you on mute, Egia. Okay, are you there? All right, so please speak. We can't hear you. I don't know whether, are you speaking, Egia? Okay, Dr. Sadebe, you're welcome. I've asked you to unmute, Dr. Sadebe, and I'll be making you co-host. For those who don't know, Dr. Sadebe is one of the coordinators. She's the Southeast coordinator. So all those of you from the Southeast, you'd better note her name down, reach out to her through the Hub WhatsApp forum. All right. You're welcome, Dr. Sadebe. Please go ahead.
Thank you very much. Okay, I want some members to help me clarify this. I'm talking of what I learned yesterday, what I had. I don't know if it is correct, yes. Our resource person was telling us that for data we gather at the lab, that we have to make it double, 1 and 2, so that at the end we can be able to get the mean of the two. And the mean will now become our working data. I don't know if I'm correct. Can somebody help me? If you can remember, we were working with samples of rice,
yes,
maize, millet, and so on. And for each, there are 2 of them. Rice is 2, millet is 2, and the rest of them is 2. I can remember I had him say that it is double so that we can collect the mean. Can somebody help me make it clearer?
okay. Those who were very active yesterday, let me pull up my participants list. Sorry, we couldn't hear you, Egia. You might need to check your connection, but whilst you're trying to check your connection, if you're on a headset, check and make sure that your headset is connected. So let me look for those who were very active yesterday. Chioma was very active. Thank you, Chioma. Please unmute and speak. She was very active.
Okay, I would like to answer Dr. Sadebe's question.
Fantastic.
Like when I was doing my research, I was asked to make the data or produce the data in more and more, like, you know, in sciences, when you're running an experiment, you're supposed to run it more than once. You understand? Because of that error, that's why you have that standard error margin. Because of errors, you're supposed to once, maybe 2 or 3 times, so that you'll be able to get the mean, to be able to counter in it. So that's what the resource person was saying yesterday, that your experiments are supposed to be maybe in duplicates or in triplicates, so that you'll be able to give room for errors. That's what I actually understand.
Shoma, in case you don't, okay, before I respond, somebody else was raising their hand. Kosoko, let me allow you on mute so you can speak. Were you trying to answer the question? I saw your hand up before the others. So Kosoko on mute. Yes, good. So speak.
Okay. Yeah. Good morning.
Morning.
Good morning, everybody. Yeah. Just want to answer the question, just to add to what has been already said, that having it, the results in duplicate or triplicate will also allow you to know if there is an error in your readings. Because if you have one, let's say it's 5, or probably 2 is 5, you're having the third one going to 15, definitely you will know that, okay, this is an error. Probably you have to, just to be able to give you a guide in what you are doing. And like it was reported, we learned yesterday that having in duplicate or triplicate is what the SPSS will allow to run a standard test. Thank you, ma'am.
Thank you so much. So for all those of you that have answered, in case you don't know, Dr. Sadebe just used reverse psychology on you. She understood everything. She wanted to involve you in the discussion, and you did very well. Thank you so much for that, Dr. Sadebe. Good.
Thank
all right.
you.
There was another hand up. I think that's Ebele. Let me allow you on mute. Just a second. I think we will just allow everybody to unmute themselves if you want to, but if anybody comes in and there's a lot of background noise, I'm going to have to withdraw that right. Thank you. It's that privilege. Thank you. So Ebele, please unmute and speak.
Hello, can you hear me?
Yes, clearly.
Okay, thank you once again. I think the second speaker actually spoke my mind when it comes to having duplicate, triplicate, because I remember the facilitator clearly stated that for those of us in physical sciences, is actually a kind of best practice. That's just what I understand. I'm not in physical sciences, but I believe that is a best practice to, like, when you're running things in the lab, to have at least 2, 3. At the end of the day, you're getting the mean. Is more to make your data more robust and minimize error, just like the second speaker spoke, pointed out. So I think it's just the best practice actually to get like 2, 3 data, and then you're getting the mean of those, and then you use it to do your ANOVA, MANOVA, or whatever you want to do. It makes it more robust. Yeah, thank you.
Thank you so much. Thank you. Thank you. Egia, I think you can speak now. Egia.
Okay, good morning.
Finally. Morning, how are you? Yes, we can hear you now.
My network got strike. That's why you couldn't hear me that time.
All right.
Yes. Regarding yesterday class, after the training, I went back trying to do the data analysis. But my challenges was that my variables at the end of the day, it differ with the one that displayed during the training. I don't know whether the mistake is from my side or I missed some steps.
Okay, so what will happen is, if you could just keep that question when he comes. I hope you have your data sets ready.
Yes,
so
yes,
but he might ask you. Good. So he might ask you to pull it up, it up during the discussion, depending on how much time we have. So we're still waiting for him to join. I hope his network does a lot better today. Haven't heard from him.
Hello, hello,
yes.
Dr. Zainab.
Yes, Dr. Sadebe.
Hello.
Yes.
Maybe he can tell us what he did. So in case we have things to say.
Okay.
Let him tell us, since we are still waiting for the resource person. Yeah.
Yes.
Let him tell us what he did.
Okay, all right. I agree. So Egia, are you still there?
Okay, yes, I did the mean, the standard deviation, the standard error, the one way ANOVA it did.
And you used the same, same, okay.
The same data and the same procedure.
Okay. So I don't know if anybody has any comments or questions.
Yeah, is it possible to see your screen?
Okay, so let me allow him. I think you're allowed to share screen. I've allowed you to share screen.
Okay. Now, currently, I'm not with my system.
Oh, sorry about that.
But in the next 20 minutes, I'll be with my system.
Okay.
Maybe,
all right.
Maybe then I'll be able to share it.
Sure.
Okay.
All right. So is there anybody else who has anything they would like to add while we're waiting for our resource person? Mrs. Salisu, your hand kept going on up and down. Please speak.
Thank you so much. Good morning to everybody.
Morning.
It's good to be here once again. Just like I said, one cannot get enough of any statistics package. One cannot get Python, our program is we have to keep going on and on. We can't learn it all. And I must say here categorically that what the hub is offering us is gold. I mean, and let me use that word because I know what most of my colleagues go through to pay the statistician, and even at the end of the day to even interpret based on your area of understanding and specialization, they will drill you. And at the end of the day, thank God something like this is coming up. It's a wonderful initiative that even at the end of the day, you find out that most of them don't even know what they have interpreted. How had a personal experience of taking the bull by the horn to dig further and found out that what the person did was even wrong. I mean, just to harness the power of learning and appreciate why we are here, not just take it for granted. Before you can see any statistician at all and ask a simple question as simple as, how do I know my data is normally distributed? You have to pay. I know some of my colleagues that went through the PhD, I'm sorry, I don't want to mention the name, they know what things are getting better now with so many resources we have online to learn statistical package, and we have been able to see better, know better, which I will encourage all the master students, the current PhD to know. You have the power when you learn things yourself, be able to do it your way, and this is one of the things this wonderful org is provided. Having said that, which I'm grateful for, I just want to ask the fact that replication, any statistical method, the reliability is basically on the replication of data. If you want your statistical analysis to be reliable, you have to replicate. That is the essence of having 2, 3, 4 and 5. And sometimes we even have calculations for it based on your area of study, like most of the maybe biomedical research, like when you do in vivo studies and all, you have to have like up to 5 or 6. All this ensure you have a statistical significance across your data. And that is where your package or whatever method you want to use will actually rely on, is on the replicate. And all this will allow you to have a reliable outcome. And of
Looks like we lost her somewhere. We can't hear you anymore. Okay. All right. Thank you.
I was muted when I was talking. Was I lost anyway?
Yes, because we could hear. It looks like you were still on, but we couldn't hear you anymore.
Okay, where did I stop?
You were saying something about that. Okay, now I've lost my train of thought. Okay, yes. Thank you.
Okay, I said in addition to appreciating this skill, it's transferable, it's applicable everywhere. I said the essence of having 2, 3 replicates lies on the reliability of the statistical methods ones want to use.
Yep.
And I said, in addition to that, you even have the way we calculate it based on your area of research. I said, for example, in biomedical research, where we use rats, animal models, many other laboratory animals, we have to do like 5 or 6 to make statistically significant. So the essence of the reliability, the assurance of your outcome relies on the number of replicates you have. And so if you're sampling a population, maybe like those in social sciences, you could have more than that. But for biomedical research, you want to have like 5 to 6, not necessarily the 2 or 3. I'm just trying to buttress why there's need for you to work with replicates,
more than
not just one or 2. Yeah, that's where the power of the statistical method lies.
I agree. I agree. Thank you so much. Thank you.
Yeah.
All right. So is there anybody else who has something to say? It's taking our resource person a while to get here. Am I muted?
Somebody's handing this up, please.
Yes, please, just a second. I have something popped up on my screen. I was trying to clear it. Uchechi, another very active voice. Uchechi, please unmute and speak. Doctor. Morning, how are you?
I'm very well, ma. Thank you very much for organizing this. I support what Dr. Mrs. Salisu said. In fact, it has been so nice. A lot of us have been paid to get trainings like this. But I don't know if it's possible for someone to take us through what was done, because I have the data on my system right now. I have the data Mr. Gada sent yesterday. If somebody can take us through, maybe we can practice before he comes online.
He's online now. I'm
have-
happy, very happy to inform you. I can see his name on my screen. There he is. Yes. So you're welcome, Mr. Gada.
Thank you very much.
There are 49 people waiting for you.
Okay. I am coming late this time again. It is not intentional.
No problem.
And presently I'm connecting with my phone because I've tried so many things. I don't know. I was connected earlier on. I was connecting to Zoom actually, but I was trying to secure power. And then I discovered that by the time I was coming back again, my hotspot was not working. My computer was not connecting to internet again. I don't know.
Sorry
why
about that.
So what I'm going to do, I'm going to send a PowerPoint slide to you, Dr. Zainab, and then if you can help me share, I think we can.
Okay, sure.
Yeah, so that whatever we have, I think we'll just save the time instead of staying too long and not doing anything.
Okay. If you have it on your system, you can actually share, except if it's not related to today's discussion.
I'm not using my system to connect.
Oh,
now.
I get. Yes, please. So please send it to me.
I want to see.
Okay, sure. Send it to me.
Okay. Let me see if there's a way I can share from here. Okay. Let me just send it to you, Ma, so that
sure.
The system is not the phone is not even allowing it to share.
My WhatsApp isn't on my laptop right now, so maybe you should, in addition, send it to my email. I'll send it to you now. In addition.
Okay.
I'll see which one comes on first. I can connect, but sometimes it gives me issues. I don't like that annoying noise WhatsApp makes when you're in a webinar. So I usually disconnect my WhatsApp except when I need it for the presentation. I just sent you my email address.
Okay.
Have you seen it in the chat? I sent it as a direct message. Or if you send it on WhatsApp, I can forward it to my email. It makes it easier for me to open on my system.
Sunday.
Okay, somebody was asking that the person, I think today is his first time of joining, is asking about, please, I don't understand what they mean by replication of data.
Okay.
Let one of the participants respond. That's how we'll know the impact. Yes, although we've discussed it, but let one of the participants respond. Let me call on who again? Where's Gospel? Gospel was so active yesterday. Looks like he's unable to join today. Gospel, are you there? If he's not there, then there was a Didion. Who else was here yesterday that I remember? Chioma has answered. I don't want to put her on the spot too much, but okay, let's go back to her. You see, every good turn deserves every hard work deserves even more hard work. So Chioma, please answer. He wants to know the meaning of what we mean by replication of data.
Okay, I think I'll say that replication of data means maybe if you are doing experimental or maybe analysis or something like that, doing it more than once, you have to get the results more than once. Maybe if it's an analysis or something like that, you do the analysis maybe 2, 3, 4 times. People have clarified the reasons why it should be so. So that is what it is, replicate the data. Performing the experiment more than once, so you'll be able to get more reliable results. and be able to get the mean of the results.
Yes. And one, I don't know if it was you who answered, or was it Uchichi who said, who went on to give an example of, for example, in the physical sciences, one of the reasons why you do it, it applies everywhere else, but the person specifically mentioned physical sciences. So for example, let's assume you're testing for, let's say, the quantity of moisture in, let's say, particular soil. The first thing you do is you first do the first one. Let's assume for the first one you got 5, the second one you got 5, and you're doing the third one and you're getting 15. It kind of tells you that something is wrong somewhere. So I hope I have not confused you, Victor. Samuel wants to say something. I think you have the power to unmute. Samuel or Risanjo, I think. Samuel or Risanjo. Please pronounce your name. I'm sorry if I didn't pronounce it right. Samuel? Your hand is up. I've asked you to unmute. Okay, all right. So let's not waste any more time. Let's go ahead. He's probably having network issues. So, Mr. Jeremiah, thank you. Please go ahead.
Okay.
Have you sent it? I haven't seen it.
Yeah,
Did you send it?
I'm trying to.
Okay, all right.
Sorry, I hope you're hearing me now.
Yes, yes, clearly.
Yeah, when we talk about replication, we in physical sciences, you replicate in order to have the accuracy of your data. Because if you don't replicate, you are not sure of repetitiveness of that your experiment. But when you replicate, it means that you are taking care of some other variables that we actually bring some error to your data. So replication actually helps the accuracy of your data. Thank you.
Thank you very much. Thank you. All right. Please mute. I do not want to take the powers of allowing you unmute yourselves away. Please keep yourself muted. Thank you. Don't let us wield the big stick. If we go ahead, it will affect the quality of our presentation. So, okay. Oh, yes. It just popped up now in WhatsApp.
I tried sending it via mail. I saw the thing was taking time, so I just had to go through the WhatsApp.
Okay. All right. All right. So let me, it's going to be a bit of, well, I'll do that. Just give me a second.
I'll just try to give a recap of what we have done so far.
Sure.
Okay. So, good morning, everybody. So sorry for coming up this late. I was already prepared, but many things happened. So from the beginning, we looked at tools for data analysis, and then I have a few guide to knowing what kind of tool you will use when running your analysis. So while we have also looked at some analytical tools, these include your Excel, your SPSS, your Stata, your SAS, Origin, and as many eViews and many others. We have also discussed that those ones, sometimes they come handy, and the R that we studied a few weeks ago, those ones, they come handy when you know certain tools that you can use, statistical tools that you can use. But You cannot just wake up and say you want to run an analysis without considering what your objectives are, what kind of result you want to attain or you want to get. From your objectives, it will be very, very easy for you to know what statistical tool you want to run. Now, having said that, you want to also determine the differences between the various set of data you have. Of course, the basic statistics that we have done in secondary school or in the early higher institution, you would have learned that we have different kind of data sets, the continuous, the discontinuous, the qualitative, and the quantitative kind of data. They are variables to say. You need to understand what kind of variable you are using. So in that regard, I have a table that shows.
Well, àwọn kan dẹ̀ sì tẹ̀lé náà nìyẹn.
Ẹ jí sọ fún yín, èmi ní ẹni tó fẹ́ ṣe dín, bring in competent HOD.
I have a table that shows a set of collection of data and then what kind of tool you will use. Now, presently in research, in our kind of research, there are some normally used tools or regularly used tools that I have highlighted and the conditions that must be met before you can use them. That is what I wanted to present, but I believe Dr. Zainab will help us do that. So.
Yes, I'm just opening it now.
Okay. We've also looked at data cleaning, and we have looked at organizing your data before running an analysis. And I said, doing the analysis, the steps to carrying out an analysis is as simple as ABC, but the reason behind or the principles behind these tools is what matters anywhere, anytime, in any research. So you want to understand and you want to check whether you are dealing with a parametric data or the non-parametric one, qualitative or quantitative kind, and whatever it is, you are trying to observe what kind of data, and then it will now guide you on what kind of tool you are supposed to use. I said yesterday or day before yesterday now, we said to use data analysis. Oh, thank you very much, Ma. To use ANOVA, you must have had several means or group of means that are presented at different levels. And then I said, oh, you are using paracetamol, you are using maybe vitamin C or ivermectin, and then you have them in different concentration or dosage. If you are using that, you want to check whether there is significant difference or no significant difference at all when you use these tools. When you are checking the differences between the means. So it is important to use ANOVA to separate the means. And then we looked at, maybe you want to go down, just go to the next slide. We are just going to go forward close to the end. Hello, Dr. Zainab, can you hear me, please?
Sorry, when I put it on slideshow, it obscures the controls. Yes. So where would you want me to go to now?
Okay, I would like you to go maybe to the last five or six slides, not this one.
So I'll start from the very last and go back up.
Just
go
up.
Okay, from here?
Yes.
Okay.
Or can you just go up? Just go up. Let's see. Just go to maybe three more above. Next one. Okay, that's okay. So
this or this?
No, the next one.
Okay.
That's so
this one?
Yes. This one now is it's giving you a condition for using the student t-test. On what ground are you going to use student t-test? Are you taking the student t-test for your data set? That's your data to analyze your data generally. So in this case, you see a write-up there. It is used to examine whether there is a significant difference between means of two groups. Now, you know, at different levels, you're observing whether using ANOVA now, you're observing whether there is significant difference. But this one now, you have two distinct groups and you want to check whether there's a significant difference between them. Now, between groups, not among groups. ANOVA helps you to check among the group, that's at various levels. So there are three different types of the t-test. We have the independent, we have the paired, and then we have the one sample. So all of these are, if you look at them, there are conditions that must be met. So quickly, the next slide, please. The next slide, please.
Yes, please just give me a second.
Okay. Okay. So from here, you observe that the goals there just involve your objectives. What do you really want to do? What are you aiming at? Are you describing one group? Are you comparing a group to a hypothetical value? Are you comparing two unpaired groups? Are you comparing two paired groups? Or you are comparing two or more groups with more levels? So you see, all these ones, that you must understand that there are certain tests that must go along with them. You cannot just wake up and just want to run analysis without considering the principle behind those tools. So you're using your mean and your standard deviation to describe the group, that's a particular group that is replicate. Somebody asked of the idea of the replicate thing. So the replicate, you are just trying to describe, that's the descriptive statistics we are talking about. So you are describing the group by just presenting the mean, you calculate, determine the mean, and then a standard error or standard deviation. I said the other day, yesterday, that standard deviation most times gives you a higher value, while standard error brings a lower one. So most times you want to present a better picture, although anybody could take your data and run and see whatever it is. So are you comparing also one group to a hypothetical value? Then at this point, one group to another one, you are using a one sample t-test. If you are following under the parametric or the normally distributed data. That's another thing. You want to check also whether your data is normally distributed or not. If it is normally distributed, there's a very, very simple way of knowing. You plot a PP or QQ plot, and then you see how your data, your data are arranged. Are they close to the straight line? In physics, we did something like that, if they are normally distributed or not normally distributed, and then non-parametric. So for the non-parametric, you are considering the median, the quartile, and the interquartile range. But in this case, to compare one group to another group, for parametric data, when you have a parametric set of data, you are using the one sample t-test. Just get the principle. You can obviously go to check what one sample t-test does and what ground are you to use it. So, and then also the non-parametric, we have the one sample Wilkinson test. Then to compare two unpaired groups, when you have two unpaired groups, those groups are not paired. When your set of data are not paired, but they are two distinct groups, then if they are parametric data, you want to use independent sample t-test. So they are independent of themselves. And at this point, you are comparing them one against the other. Then if you are comparing two paired groups, now you have two groups, but they are paired one against another. So at this point, you are going to use paired sample t-test. That's just the principle behind the three different types of t-test we have talked about. Then when you are comparing two or more groups with more levels, two or more groups, like I said, you are doing a test, a research, and you are testing paracetamol in a particular organism, and then you are testing another drug, maybe vitamin C or ivermectin. So if you are testing these two, they are two distinct, they are two different groups with different levels. So the levels could now be on paracetamol, you're using 200 milligrams, you're using 100 milligrams, you're using 50 milligrams, and like that. In that case, all you are doing is they have different levels. So you are comparing this group with different level against another group with another level. To do that, you need now the ANOVA. Now, it could be one-way ANOVA, it could be two ways ANOVA, it could be whatever. Now, the principle behind one-way ANOVA is when you have one independent variable with two or more dependent variables, two or more. It could be two, it could be three, it could be four dependent variables. At that point, you can use one-way ANOVA to determine the significant difference among the group of means. Then, if you have two or more independent variables with dependent variables, then you want to use two-way ANOVA. That's the difference between one-way and two-way. So at this point, you also want to look at to quantify association between two variables. Level of association. Does this connect with this? Is this influenced by this particular thing? So you are considering as level of association. At this point, you want to consider the Pearson correlation, you want to consider regression, you want to consider chi-square, Ox ratio. But it also depends on whether it is a parametric data or non-parametric data. So if you look at it very well, you will see that the Spearman's rank correlation is used for non-parametric data, while the non-parametric regression will now be used for also non-parametric data, and then simple linear regression, multilinear regression, whatever the case, Pearson correlation generally can be used for parametric data. So please, the next slide, please. Okay, so this also is telling you the different kind of variable and the kind of test. So by the time, if you have known the various kind of variables, categorical, non-categorical, continuous, that's the continuous, either categorical or continuous. So whatever it is, you want to see the different kind of tests that you can use. The next slide, please, ma'am. Okay, so this is also showing us the same thing. Is it single, different with different levels? Is it categorical with different levels, single or double, whatever it is? If you follow this table, you'll be able to know what kind of data tool you can use. That's the analysis tool to use. The next slide, please. This should take us now to result presentation. So when you want to present your result, after doing your analysis, the next slide, please. The very, very important thing you want to consider is you want to have a table that summarizes everything. Now, this is a research work that was done on, is like a genetically modified organism that was done. The table there, you see the title there, plant height of yellow, white, and the GM is the genetically modified maize as affected by sunlight exposure in various hours. So at various exposure level. So we have the Y6, the Y8 underneath. This is a concise way of presenting your data. Underneath, you have your key that explains anything you are talking about. So you see the GM means the genetically modified, the Y is the yellow, the W is the green, sorry, the W is the white, and then the GM, the genetically modified. So if you look at it, what does at the base there, you see what each code, if you want to call it that way, each code mean. So very importantly, you want to put in your mean values. Now you see it is at various exposure. You see 2 there. There's supposed to be a row that shows 2 up. You see 4. You see 6, and then you see 8. So if you look at that, those times means time in hours. So 2 hours, 4 hours, 6 hours, and 8 hours. So exposure to sunlight. So there is a measurement that was done, or determination of data that was done if you look at Y6, if you go down to our description, you see that Y6 means yellow maize exposed for 6 hours. You know, it was exposed for 6 hours, and then the data obtained there was 19.00 with a standard error of 1.07. Now you see a superscript up there. That means you have used either a Tukey or a Duncan to separate your mean. We did that yesterday. So using your Tukey or Duncan to separate your mean, from the highest, you begin to count, or you begin to label A, B, C, D, E. When they overlap, you now know that it is going to be A, B, B, C, or A, as the case may be. So in this case, that of 19, the one with mean value 19 was the highest, and then it has a superscript of that then you see 19, you see 11, 15, 14, 4 weeks, a concern data. And mind you, this data can be automatically arranged in your statistical package if you arrange your raw data properly. If you organize your data properly, you do your cleanup, your cleaning very well, you can have it arranged. But you can, it's difficult for you to have your mean and your standard error together. So that means you have a row. If you look at the one we did yesterday, the ANOVA we did yesterday, you have a row for mean, then you have another row for standard deviation and standard error, another row. So you have to merge. So here we left the standard error and even the mean in 2 decimal places. So it was just allowed in 2 decimal places, and then the separation was made. So this is a simple way of arranging your data. Then underneath, you see the p-value. On the same table, underneath, you see the p-value, and this p-value here is telling you whether there is a significant difference between or among the various means down the column. If you look down the column from 19 down to 12, you see that you see that the p-value there, the mean separation or the level of significance here of the various means is 0.034. This is now in 3 decimal places, 3 decimal place, I mean. So at this point, can we say there is a significant difference or there is no significant difference? Remember, we said when your p-value is less than or equal to 0.05, you have a significant difference. When your p-value is greater than 0.05, there is no significant difference. So from here, you can obviously discover that all the various light exposure, the data collected for each of these exposure is not the same. So the yellow maize, now let's look at the yellow maize. We have yellow maize at exposed at week 6, week 8, and week 12. So if you look at that, you have for week 6 at 2 hours, yellow maize, okay, exposed at week 6 at 2 hours. So the first 2 hours, the first column there after the hours of exposure, you have 19.00. So the second one that's Y8, you have 11.10, and Y12, you have 15.60. So at this point, if you look at it, you observe that there was a higher mean at Y6, followed by Y12, and then Y8, which is 11.10. 0.10. So, but the mean separation was done for all of them. You can save yourself some stress to talk about just the yellow maize and then the white maize, then the genetically modified ones. So for the yellow maize, if you want to separate, simple, I want to show you something. Instead of running through Duncan, yes, Duncan makes it easier because machine they say makes work easier and faster. But you having the knowledge, the background knowledge of this mean separation, you can easily tell which of them is still going to be A. Now let's look at the Y, the group of Y at the 2-hour exposure. That's Y6, Y8, and Y12. Now between 19, 11, and 15.6, we have to take note of the decimal place also. Now, if you separate, you look at 19 is higher than the other two. In our mind, we will say followed by 15.6 and then 11.10. But how do you separate these means now? Look at 19.00. It has a plus or minus 1.07. 1.07. Now, if you remove 1.07 from 19.00, you know you are going to be getting you're going to get 17.93. You're going to get 17.93 if you separate 1.07 from 19.00. So that means your 17.93 will still be higher than 15.60 and 11.10. It will still be higher. If you add it, it is going to be 21.07, which is still higher than 11.10. So I'm giving us, so sometimes you could see a particular work. For some of us that do review work, you review a particular journal, you review journals, you look at somebody's statistical output, you can tell without getting the raw data by looking at the standard error, standard deviation, to tell whether the superscript are correctly placed. So in that case, 19.00 would automatically be A among the yellow maize, the results for yellow maize. Then if you come to the next one, 15.60, if you subtract 0.21 from 15.60, you are going to get 15.39. You're going to get 15.39. So that 15.39 is still higher than 11.10. So that means your 15.60 will also carry a superscript B. Is going to be the second, is going to be separated to be the second in the list. Then 11.10 will now carry C. So if you are separating, that's if you are doing it manually, but of course we have Duncan and we have Tukey that can help us to do this separation easily without stress. Now that's for those that you just pick a particular research, somebody's publication, and then you want to review, or you are looking at it to criticize, kind of. So you can use that same method to check for others. That is just about that. Now, we have seen a simple way. We'll be coming back to this, but let's go. Yes, we have come to the next table now. This other table is also looking at number of leaves. Now, at this point, we are not now looking at just a general mean of length. That the other one was the plant height, kind of. But this point now, we're counting number of leaves as a result of exposure. Okay, some of the seeds were exposed for 2 hours, some for 4, others for 6, and the rest for 8. So at this point, we have number of leaves that were obtained. Now, the yellow maize, the white maize, and the genetically modified maize, you can observe that they have different mean value and standard error also. So at this point, we can also do mean separation. Okay, can we just look at, I'm just trying to see an overlap. Somebody was saying we should try and get an overlap where we can get. Now look at under the column 6, on the row where you have GM6, that should be 1, 2, 3. That's the the third row from below, or the fourth one now, including the p-value. You observe that these 6.20 appear in A, the column for A, and it's also appearing at the column for B. How do we accept this fact? Now let's just prove it quickly before we go into the result discussion, whatever. Now look at that 6.20 plus or minus 0.12 carrying the superscript AB. Then look at the one that's carrying A. The one carrying A is 6.40 plus or minus 0.05. Another one carrying A is 6.40 plus or minus 0.35. So let's see if there is an overlap between the one that's carrying A and the one carrying AB. So the first thing you do, I said, you have to do the plus side and then the minus side. If your answer, the result you are getting is overlapping with another one, then they are in the same category. That's what it just means. So for the first one, the one carrying A, we have 6.40 plus or minus 0.05. The one with AB is 6.20 plus or minus 0.12. So the one carrying a superscript of A, I don't know if it's my phone, but I'm not seeing the table again. But okay, thank you. I can see it now. Okay, so the one carrying A, let's subtract, because if we add, it's going to be higher than every others. So let's subtract. So let's subtract 0.05 from 6.40. 0.05 from 6.40. You are going to get 6.35. You're going to get 6.35. All right, so 6.35. Now bring it to the next one where you have the superscript AB. You have 6.20 plus or minus 0.12. If you add 0.12 to 6.20, you are going to get 6.32. So 6.32 and 6.35, they are set in the same category. That is why that one is in A, while this other one, instead of also being A, but it is less than A, will now be AB. I want to believe we understand what I am saying. So that is just the place of the overlapping that somebody was asking yesterday. If we had on the SPSS or our software, if we had done any analysis, and then we have that, maybe we would have. I'll put that in the PowerPoint when I finish up the PowerPoint to send. So I'll put something like that so that we can easily see. So this is the simple way of data presentation. So there are many other ways you could present your data in form of charts. You could present your data in form of graph. You could present your data any way you deem fit. But if you are putting it in a form of table, and then mind you, there's this acceptable way of presenting your table. Most times you should have just 3 lines. You should have just 3 lines. 3 lines, yes, 3 lines. So 2 lines showing the heading of your work, your table, and then the last line putting a boundary from the start to the end of your table. So it should just be 3 lines. That's just a guide. So can we go to the next one, the next slide, please? Okay, there's no slide down. Okay, fine. So how do you now discuss? That should be the next thing we should look at. How do we now discuss? How do we now discuss these results so far? Now let's look at this one quickly. If you want to discuss these results, you want to ask yourself simple, and this is where literature review come into play. You want to ask yourself simple question like, what would be the reason why this particular, maybe the yellow one or the white one or genetically modified one is having more leaves? Now, one factor could be the presence of hormone, an increased hormone. I'm thinking I have to check literature to be able to get that. you know. Then you want to also ask yourself simple question like, are there certain factors that would have caused this? So by reading, you can now say, okay, this one is having so and so, is having this length or this height or this number of leaves because of, possibly because you didn't check for that, unless you went to the lab also to confirm the presence of that particular thing that may have caused it. You would obviously say possibly because of the presence of this as presented or carried out by so and so researcher. You know, you have to cite somebody. So that's when you are discussing that result. But very importantly, present the result presentation. By the time you are writing, you know, there's, aside from just presenting your table, there's also the presentation where you say something, the summary of whatever you have. You are looking at certain values or certain data mean that stand out, maybe the lowest or the highest. So at this point, you are in this place of the leaf. I'm going to just quickly run through and look at, which one is the highest. I'm seeing 1.6 under 2 hours of exposure. I'm seeing 1.6 at Y8. And then I'm also seeing 1.8 at GM12. So I'm seeing that Y8 has the lowest of all. So I could say that from the result obtained, it can be observed that Y8 yielded or presented the lowest number of leaves when compared with others. White, that's the yellow, the white, and the genetically modified. So it presented the lowest. And then I'm also looking for the highest. And then I see 2.4. I see, yes, 2.4 at GM8, so genetically modified. So from here, I can also discuss and say, oh, it is possible that the genetically modified organism at GM8 yielded more leaves because it's a mean. It's mean. If you check the raw value, it may be somewhere around, maybe the raw, you may have the one that is 5, you may have the one that is maybe 3, as the case may be, and at the end of the day, you have a mean of 2.6, 2.4, I mean. So at this point, somebody would want to say, oh, maybe due to because there's a genetically modified influence on these crops, we can say, oh, the gene that has been modified could have caused an increase in, but anybody can debate that because at GM12 we have 1.8, and so a researcher could also say that maybe high amount of the genetical influence could cause reduction in the leaf, where moderate amount, you see GM6 2.0, GM8 2.4, and GM12 1.8. So you could say, oh, maybe a moderate amount of the genetic influence. It could be a chemical, or something. So that's maybe a moderate amount could yield higher number of leaves in that case. So you just have to go through, look at your data set, your descriptive data, and then from there you can present your results, and then you can also do discussion. So this is just a brief summary of what result presentation and discussion is all about. I know this is the last day of our presentation. I'm going to ensure that the data are, the PowerPoint is presented, is given. I'm going to do it very well to make sure it's self-explanatory, and then anybody can use and learn from there. So thank you very much. I see some people raising hands already.
Thank you so much. I wish you were here at the beginning when we're doing a review. So you've made a lot of impact. But having said that, before I start letting people ask questions. Please, we'll be posting a link in the chat box. If you could just please help us fill it. It's a survey of the workshop, as I mentioned earlier. And then before we close, we'll also be doing a group photograph. So if you could just turn on your screen when the prompt comes up just before we close the meeting, I'll be very happy. Thank you. So whilst I'm posting the link, let me start one by one. I'm sorry if I don't get you in the right order, but the first hand I saw up was Mrs. Salisu's. Moreover, she's a lady, so I'm allowed to be partial. So Mrs. Salisu, please ask your question. Thank you.
Gender bias.
Yes.
Okay.
Let's
good.
reverse it.
We're good to go. Yeah, I'm looking forward to when we're going to have the female statistician in the hub to give something more better than this. So we'll be a good, your good student very soon, Mr. Agada. Thank you so much for the presentation. I want to take you through the table 2 that you explained. I saw under the key for the table where you have P less than 0.05 due to DMRT. I want you to tell us what that DMRT is. And that is what, then in addition to the discussion that you said, you could also agree with the findings in the literature or disagree, or probably the first time something is coming up and you'll be able to like tell them that this is coming up, maybe, like you said, just to add to what you have said. So it's not, most times we are usually maybe because of the part of the negativity we were exposed to during our PhD, we're always looking for something positive to buttress our research. We always work towards positivity. Sometimes we have a negative result or it doesn't align what is in the literature. It's also part of a good discussion that we should not be afraid to discuss. Thank you.
All right. Would you like to answer that, or you want us to take more than one?
Okay, let's take the second one. I would like to join them together.
Okay, all right. So the next hand up is, if you're unfortunate and I see another lady, I'm going to take her over you. But I think the next person I saw is Samuel. Samuel.
Okay.
Samuel,
Okay. Okay, thank you so much. I hope you are hearing me.
Yes, we are. Thank you.
Yeah.
Uh-oh.
Yes. Thank you, Mr. Gada. Looking at the table that you share with us, that's table 2. When you look at week 6, I noticed that there may likely be an error there. Because if you look at the first data there in week 6, you see 3 point something, and you put B there. And we have 6.0 something in the other way, if I'm very right, which I've checked, and you put B there. B means that they are not statistically significant. But
Okay.
it's not true.
Which one is that? Is it this table or
error, when you look at
is
the
it this
standard
one?
error, yeah, that is the table. That's the table.
Okay.
Yes,
all right.
it's the table. Look at week 6. When you look at week 6, yes. When you look at week 6, what we have there in the first row is 3.80. You look at the standard error plus or minus 0.31, you put B there. But when you look down, check other B. Towards the end, you will see 6.0 plus or minus 0.13 B. That cannot be true. Because if you look at the standard error there is no way there won't be a standard difference between those two variables, two data. And then when you look at the overlapping that you are trying to explain the other time, about 6.20 plus or minus 0.12, and with that 6.40, there is no how A and A can be, because when you have A and A in the first instance, it means that there is no statistical difference between them. It is when you look at comparing with B that makes you to have overlapping of AB. So I'm a little bit confused about those data there. And so you may need to give me some explanation to be sure that that one 3.80, which is B, is not any different from 6.00 B that we have there. I think there may likely be an error over there. Thank you.
Okay. Thank you very much. Dr. Zainab, I see one Uber is raising hand. Please let me just clear this too, then we can continue. it just means that we have learned, and the questionnaire has the person that asked the question obviously has learned, and if this is the first time you are getting this, then fine. It is interesting, you have learned something. So that's 6.0 plus or minus 0.19 and 3.80 plus or minus 0.31. That's an error. That's an error. I just observed that is an error. And then it is simple. Sometimes you may have seen the mean separation, and then you are trying to transfer. There's a way I do it. Most times I get my superscript instead of just typing and then put in the superscript. This is the work of actually a student doing her master's degree. I think she has defended and she has gone. I am surprised, possibly, except she changed it, but this was what she presented, so it was not so good. Now, the simple idea is that 3.8 and 6.00, that's a typographical error. Is a typographical error. If you see the raw, so the output, it will not be exactly like this. And then every others. I also discovered 6.20 and 6.40. 6.40 to be A and 6.20 to be AB. If we check the if we check the mean separation, it will be difficult to see that it is going to be different like that. They may be AA. Yes, they may be AA. So that's where now your ability to know and criticize come into play. So it's good we have a very good critic among us, and that's a good one. So you can be a very good reviewer for any journal considering the statistics of a research. Now, then the first questionnaire said there was something under where we put DMRT. I'm trying. Okay. Standard error. The superscript with different letters are significantly different at p-value less than, supposed to be less than or equal to 0.05 due to DMRT. DMRT means Duncan multiple range test. So that means it was Duncan that we used to separate the means. That's what it means. So due to Duncan multiple range test. I don't know if there's any other question there, but that's the answer for me.
There's one more hand up. There's Umar Sani. So I'll just click and tell him to unmute. Umar Sani, please unmute and speak. Ask your question. We're doing really good with time today. Yes, please ask. Sorry, Umar Sani, sorry. I'm sorry, Umar Sani. There's a lady's hand up. I'm sorry. Dr. Uchechi. Dr. Uchechi, please unmute and speak. I'm sorry, you are outnumbered here. The ladies are outnumbered. All right, Dr. Uchechi, please speak.
All right, thank you very much, Doc. Thank you so much, our resource person, Mr. Agada. But please, I kept on disturbing you since yesterday. I still have my data and I've not been able to analyze it. I don't know if I can share my screen here. I'm sure a lot of us have the same issue.
Yeah, whilst we would like to do that, unfortunately, we're a little pressed for time. So you're going to have to reach him. You're going to have to reach him, on your own time, at an agreed time between the two of you. I'm really sorry. I wish I could permit that. Sorry. Right. Except maybe when we're done taking all the questions in their time and he's happy with that, then we can take allow you to share screen. Okay. All right.
Thank you.
So Umar Sani, finally over to you. Pray another lady's hand doesn't come up.
Hello? Hi.
Yeah, please go ahead.
Hello, good morning.
Morning, how are you?
I'm fine. The lecture is very interesting and satisfactory. Me, I just wanted to ask on yesterday lectures.
Okay.
I'm here with my SPSS open. I followed the procedure of yesterday in order how I can export. I input my data from my desktop to the SPSS, but I couldn't. I followed the same distinct procedure like yesterday. And I have issues on that one way. I know by this part that there is no time, but at least if I was being shown or explain how to export it into the SPSS, maybe from there I can catch it up. Thank you very much.
Export or import? Because importing means bringing your data into, or
yes,
taking you're taking your output out.
Importing from the desktop to the SPSS.
Okay. All right. Now let me just give, I don't know, let me just give a simple way of doing this thing.
All right.
You can open your Excel.
Okay.
Highlight, copy all the data you have and paste.
Okay, I'm
on
pasting
on your SPSS sheet.
All right.
Then another way, you can tap your
on data view or in the variable view.
It has to be data view. It has to be data
right.
view, not variable. Variable view. You cannot put your data there.
All right, sir.
Yes. So the other way is to you touch file, then you click on file, you touch open, then you see new or open data, then you touch the second option, which should be open data also. When you touch that, then it is going to take you to your phone or laptop directory, wherever, either desktop or document or whatever folder you have kept your data. So it's going to show you that. Then you are the one that will now, since it is in Excel, you're also going down, you're also going to go down to check something like file in. You're going to check something like file in, and then you will now choose not SPSS, SPV. You are going to take Excel. There's a list of collection there. You take the one that has Excel in it, and so all your Excel file will now appear.
Okay.
Once here you tap on it, or you click on it, or you double click on it. If you click on it once, then you now see open under, and then you tap open. It should now give you a kind of interface where you will now choose which of the sheets. Like the one I shared yesterday, I had 4 sheets, Excel sheets in it, in that file. So you will now pick one out of them.
Okay.
You'll see a drop down, a drop down sign that will help you to choose either the first sheet or the second sheet or the third one. So you take one of them, they are all the same.
Okay, sir.
So you pick one of them, and then you okay also. Then it will lead you into your SPSS. Now there is also another problem. If your data is not well organized, SPSS sometimes will not accept to open it. At another point, if your data is opened like the Excel, you have opened the Excel already. You have not closed it and you want to open it in SPSS, sometimes SPSS will not open it for you. So you have to close the Excel sheets on the background before process going ahead with what you want to open. So there are some technicalities in these things. I'm going to see if I can check for that, and then see why. I have several systems with me, and sometimes some of them don't open some document also. I've observed that, but I've not been able to check why.
Okay.
I've not been able to check why. Yes. So I'll check if I can see, then I'll do a video, or I'll just put the reason behind on the general platform for everybody to utilize.
Okay. Thank you, sir.
Thank you so much. Thank you.
Thank
Thank you once again. Thank you. I believe we've exhausted all the questions. I think I saw a few comments in the chat box. If you just give me a few seconds to go through them. Some of them I've responded to. Somebody was asking about the slides and the recordings. I've responded to that. And then I think that's essentially all. They're asking for the recording, the slides. So I think we're good now. All right. So thank you so much, everybody. So if there are no further questions, please can you turn on your... Sorry, just a slight clarification. Somebody just posted, the link I just posted in the chat box is for evaluation of the workshop. The ones that we posted yesterday was for attendance. So if you filled yesterday, you should fill again today. I'm trying to get one for the attendance for those who didn't fill yesterday. So whilst I'm trying to do that, please let us turn on our cameras so we can do a group photograph. Thank you, everybody. Thank you. Thank you. The screen is lighting up. Thank you. Thank you. Where were you hiding all your pretty faces? Look at all the pretty ladies. Why did you turn off your camera? Oh. Please turn on your cameras. Turn on your cameras. Thank you. Turn on your cameras, please. A few more. We still need a few more. Thank you. Okay, I don't know why somebody's hand is up. Egia, you have a question. If you can just hold it until we're done with the photography. I don't know what I'm doing wrong. I'm only seeing a few faces. Please turn on your cameras. I can't see you all. Please, please, please. Please, thank you. I'll do one shot now. Dr. Doherty, if you're there, could you do another one, please? I don't know why I'm not getting everybody. Maybe somebody else can do a screenshot. Thank you. I'm not getting everybody. I don't know what I'm doing wrong.
Dr. Zainab, I'm
yes, please.
using my phone. But
oh, dear. Okay.
Yeah, you can take different...
It's only showing about 6 screens at a time. I don't know what I'm doing wrong. Let's see view. Sorry, I'm really sorry, everybody. Let's see if I can do a grid view. Okay, I'll just manage with what I can do. Or if there's anybody here who's on the hub who has everything, then please take, so we don't have to do too many pictures. I only do 5 at a time, and we have all of 55 people right now. That's so good. Is anybody able to? Dr. Sadebe, are you able to do a screenshot of everybody? Can you get everybody on one screen? She's still there.
Is Mr. Shokubi there? Maybe he can
I
also
didn't
take a screenshot.
I didn't see his name on the... Mrs. Salisu, are you able to do a screenshot of everybody? I don't think she's hearing me. Okay, let me just go one at a time and see what I can do. All right, I think I'm almost done. Shift command 4. Sorry, I'm really sorry. If I was a photographer, I don't think I'll make much money making people hold one pose for so long. All right. I think I have almost the last. Okay, I think I have everybody now. So thank you so much, everybody. So if you haven't filled the assessment form, please fill it now. Thank you very much. So once again, thank you so much, everybody, for attending. Thank you so much, Mr. Jeremiah of Pennyloa Educational Consult based in Kaduna. But just as I asked yesterday, how can we reach you in case if any of the attendees would like to reach you? You mentioned those yesterday. Could you please say again, how can we reach you? Thank you.
Okay, we can connect via email.
Okay.
WhatsApp is handy.
Okay.
The email address is pennyloaec@gmail.com. That's
okay.
PENILOAA, then EC@gmail.com. Then we would also connect via WhatsApp. I saw somebody put in that would like to communicate via WhatsApp. So the number is 080-6568-0102. 080-6568-0102.
Right. So thank you so much for that, Mr. Gada. But however, I must sound like a note of caution. Pennyloa Educational Consult is a business. This he has given to us free of charge as he's volunteered to do free of charge as a member of the hub. So he might only be able to provide limited support for you free of charge. So please, I beg of you, you need to understand he is running a business and he will decide who he wants to deal with on the terms agreeable to both of you. Please, I beg of you. Thank you so much, everybody. Dr. Mina is raising hand. I think we'll just take that and then we'll close the presentation. Dr. Mina?
I feel completely glad. Thanks everyone for going through this with us. My name is Dr. Mina. I'm an associate professor of development studies and social work. I just feel I needed to ask quickly because that's why is if there'll be a chance to get a certification for those who may be interested, especially for those of us who will require mandatory submission of such certificates. What do you think?
Unfortunately, we didn't make any provision for providing a certificate. So, but we're going to have to discuss with those in the hub and the coordinators and see what can be done. And then we'll get back to you. I have your contact. So, all right. Thank you so much. Thank you, everybody. Thank you. All
Please,
right.
can I quickly add something?
Yes, please. Even though our time is fast spent, but just quickly, in the interest of the season.
Okay, I don't know, maybe you can refer me to somebody. I would like to know a little bit more about the journal club that you mentioned earlier.
Dr. Mina, you're already on my journal club. Are you not the one asking? Sorry.
No, it's Ebele.
Oh, Ebele. What's your discipline?
I'm on the journal club.
I'm a pharmacist. I'm a
pharmacy. Oh yes, pharmacy. You belong squarely with the biomedicine and healthcare journal club. So if you're in the hub, please just fish my number out, send me a private message, and then I will add you. Yes, Dr. Mina, you are on my journal club. I remember you posted your TED talk on my journal club some time back. So I'm telling you that yes.
I'm going there. Boom, boom.
All right. So thank you so much, everybody. Have a wonderful the rest of the day.
Hello, just a quick one.
Okay. That's the last one I'll be taking. Sorry. Yes. Who is
okay. Please, how can I join the journal club as well? I'm a pharmacist too.
The pharmacist. Are you on the hub? Are you on the national hub?
Yes, I'm there.
Yes,
I've been there since. Yeah.
So just like I told you earlier, the person who asked the question earlier, fish for my number from the hub WhatsApp forum. Send me a direct message, and then I'll do the needful. All right. So thank you, everybody. Have a wonderful the rest of 2022 and step into good. Bye, everybody.
Okay, bye. Bye.